Good evening. Are you able to see the screen PPT?
Yes, Professor.
Okay. All of you, please mute your mics. Otherwise, sometimes whatever background noise from your home or all this thing getting recorded. Make sure that your mics are muted. Okay, fine. So yesterday we were just talking about how to make the automobile subsystem which can be controlled electronically, correct? So first thing we started, even though there are four main subsystems, which is very important, like engine, brake, steering, and transmission system are needs to be electronically controlled. Of course, if you see modern car, there are more than at least 50 to 60 electronic control units inside an automobile, high-end automobile, like Mercedes-Benz, Maybach, correct? When you are ready to pay in the order of $50,000, $1 lakh, something like high-end cars, correct? Luxury cars. You have many ECUs, I will show you later. But most important, engine control, brake control, steering, and transmission control. Yesterday, we started with how to make the engine electronically controllable. For that, we have to go, what you call as a fuel metering, electronically controlled fuel metering, which is nothing but fuel injection system instead of carburetor, correct? Yesterday I explained about how the carburetor works a little bit, which correct, because you are, all of you already working, you all know how the carburetor, because you are from this is what I told you. You will see the in between somebody talking from background, not you, your family members or your company people, somebody. It is getting recorded in this one. Make sure that as soon as entered, immediately you may put it in the mute mode, your mic. Whenever you want to talk, that time alone you do, immediately you have to mute. Don't forget, because even if I give instruction, many of you are not following. Correct? At least few of you. Don't do that. Because it is interrupting my talk also. I have to stop, I go and mute all those things. You can see that the flow of the teaching gets disturbed, right? Because I cannot tell you every class, I will not tell. Next time if you do, I will disconnect you from the class. Whomever voices I'm hearing, I can watch it, correct? I will disconnect from the class, you cannot attend the class. No, I generally tell politely, but you people don't bother like your school kids. Okay, fine. Now you know the carburetor was used for fuel metering, correct? It was used for fuel metering for a very long time. Okay, carburetor was used, but that is for fuel metering. It is a mechanical fuel metering system. Already we know that all of your automobile, this one, whether two-wheeler company or four-wheeler company, definitely you know how the carburetor works. But still, I explained yesterday how it works. Okay, but the main problem with the carburetor, already told yesterday, just to recollect, you know that what you call as vaporization, fuel vaporization. Correct? Vaporization does not happen completely in cold condition. Happen completely. Correct? When the atmosphere is very cold condition. So even though air is entering through the carburetor, correct? It sucks the fuel from here and they mix, correct? Fuel droplet size in the another problem I told you that fuel is coming as a liquid, enters a liquid in the venturi part of the manifold. The vacuum is created, sucked in by the air, and the liquid is broken into small droplets, but the droplet size are not small. Correct? Droplets are bigger. Correct? Droplets are bigger. So the droplets are bigger, so that they don't evaporate. Correct? Because at a atmosphere to 1 bar pressure only, the fuel is entering. Okay. The fuel vaporization does not happen in cold condition because the droplets are bigger in nature. As the fuel is entering room temperature, they don't have. So you don't get homogeneous air fuel mixture inside the engine cylinder, correct? Combustion chamber, correct? It doesn't. So the fuel unless it vaporizes, it cannot mix with air. If it doesn't mix with air, homogeneous mixture will not happen. So that is a drawback. Homogeneous. So that means combustion does not happen. All those things, correct? All those things doesn't happen. Then another important thing is the fuel when it enters, because I can show that in different color. So you can the fuel. Some of the fuel will be deposited on the wall of inner wall of the this is wall, correct? Inner wall of the manifold, correct? This is manifold, correct? Manifold. So there some droplets will do this one. They will just adhere to the walls, correct? That is called a wall wetting. Already I told you. Wall is wall wetting. That means some of the fuel, correct? Whatever fuel is viewed, the jet size decides the air fuel ratio, correct? Air fuel ratio is decided by the jet size, correct? Jet size means jet hole size. Correct. For the carburetor fix, you cannot change dynamically. Already the carburetor designed for the particular engine. So maximum needle valve controls the fuel going. Correct. Needle valve opening design, how much fuel should go depending upon throttle position. Throttle is vary from 0 to 10%. So the needle valve opens this one 0 to 10%. Correct. So the maximum fuel quantity when 10% throttle means the needle valve will be totally open. So depending on the hole size, correct? Depending on the hole size, the fuel will be going so many milligrams per second, or rate of fuel milligrams per second, correct? So it can enter depending sizes, and it get mixed with air, and air fuel is created. But it that means since all the fuel is not getting inside the combustion chamber, not vaporized, some fuel is sticking to the wall. That is called a wall wetting phenomenon. So, for example, during the suction stroke, correct, air fuel ratio you decided you want to stoichiometry 14.7:1. I'm talking about carburetor, correct? This is what you want to have. That means during the entire suction stroke, 14.7 grams of, for example, of air is entered into the combustion chamber, correct? This is the combustion chamber, correct? So here it is injector, but the same thing is there. So in the combustion chamber, here it happens 4.7 grams of air is entered, correct? Now, how much fuel if you wanted to maintain stoichiometrical, 1 gram of fuel should be added. The 1 gram of fuel will be added by the carburetor to the jet, correct? It enters through the hole, correct? Exactly the hole size. The jet size is such that in full throttle condition, for example, maximum power, so 1 gram of fuel is going to enter, correct? So that means it gets maximum power. But some amount of fuel is sticking here, correct? All the fuel is not good because some amount of fuel is sticking in the wall, because still in the liquid form, it is not evaporated. So that means your actual air fuel ratio will not be 14.7, it will be leaner. Leaner means, correct? So the less fuel, correct? Air is 14.7, fuel is, for example, 0.8 grams only went in, correct? So that means if you inject 1 gram of fuel goes in, then it is a stoichiometrical. Instead of some amount of fuel is sticking to inner wall of the manifold, which is called a wall wetting phenomenon. So that means only 0.8 gram of fuel went inside the combustion chamber, correct? So that means the air fuel ratio inside the combustion chamber is not 14.7, it will lean. More air is there, less fuel is there, correct? It may be 15, 16, something like depending upon you can calculate. Correct. So that means it becomes less. That means when less air fuel is there and more air is there, it is a lean mixture. It becomes a lean mixture. That means the power or torque developed. Torque developed by engine will be less. Torque will be less. Correct. That you didn't expect because you are supposed to get so much torque when stoichiometric air fuel ratio is maintained by the carburetor. But even though from the carburetor fuel is entering through jet inside the manifold, some amount of fuel is sticking to the wall because the wall is cold. Correct? Wall is cold. That means the fuel which was sticking on wall will not evaporate because the manifold is made of some metal. Correct? In cold condition, metal will be very cold. All the heat will be lost the whole night. So it will be very cold compared to atmosphere. Atmosphere temperature may 1 degree. The engine temperature, engine cylinder wall, manifold temperature may be minus also. Correct? It will already lost the whole night to this one. So that means more fuel will. So this leads to lean mixer, less power, and some amount of fuel is sticking to the wall. And when air is going fast, some liquid itself will go inside. instead of a droplet evaporate, liquid itself go inside the combustion chamber. Petrol as a liquid that will not evaporate even during combustion. It will produce HC emission, unburned combustion. Correct. So these are the major drawbacks. Valve wetting. Correct. Valve wetting is one problem. Then next one is the power is not generated because less fuel, because it is a lean mixer. So the torque what was designed was not going to happen. Correct. So even though the metering instrument, the float is sending the air, but the petrol, and it is not evaporating because cold condition, valve wetting, and as a cold temperature. So torqueless, valve wetting, and HC emission mode. These are the major drawbacks of the carburetor. For that only we wanted to go for fuel injection. Correct. In fuel injection, what we are doing is we have an injector which replaces the carburetor. Correct. It replaces carburetor. Okay. Fuel. How it is coming? You have your fuel tank. From fuel tank, fuel is coming. Correct. It doesn't come directly. What we will have is here you have one fuel pump. Correct. Fuel pump. This is the fuel tank. It is filled with fuel. That fuel comes through the fuel pump. Here the fuel pressure is 1 bar. Correct. Atmospheric pressure. So that is sucked by the fuel pump. Generally, it is an electric pump. Correct. Which is put inside the. Generally, it will be the pump itself will be inside the tank, fuel tank itself. But here I'm showing separately. The fuel pump will be inside. It is a submersible pump. Correct. So it is inside. It sucks the fuel. Correct. And it pressurizes. In most of the engine currently used the fuel injection system called MPFI. Correct. Or PFI, depending upon whether single cylinder. If it is single cylinder, there is a port fuel injection. Correct. It is called a port fuel injection system. Correct. So that is short form is PFI. If it is a multi-cylinder, like a car in 2-cylinder, 3-cylinder, 4-cylinder, it is called multi-point fuel injection system, port fuel injection system. PFI remains same, only prefixed by multi-point. Correct. Or multi-port. Correct. Some people say is multi-point because each injector is located at one point, cylinder, so, or multi-cylinder fuel injection or multi-port fuel injection, MPFI. Correct. So multiple cylinder, but they all are same. Correct. For each cylinder you are providing. So the fuel is pressurized, and the fuel pressure will be 5 to 6 bar. Some engine, correct, MPFI engine, correct. Why it is called MPFI engine? We'll see in the next slide. It may be 3 bars. Correct. 4 bar, 5 bar, or 5, 6 something. The range is from 3 to 6 bar generally. Correct. Don't say that tomorrow some engineer is using MPFI engine. My car manufacturer is using 7 bar pressure. It can be. Generally, it's not very high. Correct. It is not very high means in GD engine, gasoline direct injection, the fuel pressure may be 30 to 40 bar. Correct. In diesel engine, CRDA engine, you know that fuel pressure, diesel injected 1500 bar. Now they are going to 2000 bar. Correct. We are going to see that today. Correct. In GDA engine, it is 30 to 40 bar. In CRDA diesel engine, it is 1500 to 2000 bar. In port fuel injection, MPFI or PFI, the fuel is pressurized only up to 5 to 6 bar, maximum 5 bar. Correct. So then the fuel goes inside the injector. Inject is a electromagnet. It has an electromagnet. It has a coil. Okay. You can see that this is the electric coil. Correct. This coil gets the signal from the ECU or engine EMS system. Correct. So EMS system sends the voltage, correct, with respect to ground. This is ground. Correct. So ECU will be sending 12 volt pulses. Correct. Generally, the coil will be de-energized. I am showing a graph. This is a time axis. Y-axis is voltage applied to injector coil. Please see that this is injector coil. Cut section is short. And when a voltage applied, there's a current flows. Correct. So when current with this produces electromagnet. Correct. The coil produces electromagnet, which will pull this plunger, this one plunger. Correct. This is called plunger. Correct. The center one. Correct. It is made of magnetic material, and the end you have a small needle valve. Correct. End is nothing but a valve. This valve is nothing but a needle valve, And the end of the injector, you have a nozzle, correct? A small hole. The nozzle size in fuel injector, correct, will be starting from something around, say, 50 to maybe 100 micrometer, correct? It may be bigger also, depending on how much fuel quantity, what is the engine size. A bigger engine means more fuel should be injected. In that case, the size may be even 200 micrometer. Or so this is the engine. If you see the injector side view, it is like this, correct? This was shown here. There will be a center hole, correct? Fuel will come through this like this. Only one hole, single hole injector, correct? The nozzle size may 1500. But in case of bigger engine, if you want more fuel, means what will from bottom, if you see, this is a cone, correct? This is a cone. You will have multiple holes. Center one, side also holes, correct? This is my injector, correct? So that means each will be spraying fuel, correct? Each hole size may be some 20 micron, 30 micron. So there are 5 holes, totally large area, more fuel can be injected, bigger injector, correct? So depending on fuel quantity, what you want to inject, you can have a single hole or multiple hole in the injector. Generally, hole size will be in the order of micrometers only. You see that such a small, not even mm, we are talking micrometer, correct? The diameter of the hole, nozzle, that is called nozzle, correct? So injector end is, there's a small hole which is called nozzle. Here it is shown as a single this one. So when the ECU gives a pulse, normally the coil will be supplied with 0 volts, correct? Normally the coil will be supplied with 0 volts. This is time equal to 0, correct? For sudden, whenever injector wants to be what, ECU want to inject fuel, what it will do? It will supply a 12 volt pulse. It will send a 12 volt pulse, correct? This is 12 volts. Generally in a car, automobile, because we have a 12 volt battery, so the injector. So the 12, once it does, there's a current flows. When the current flows, correct, there's a magnetic flux will be start going from north and south poles. When it happens, we can see that the plunger, correct. So this part, correct. So this is the electromagnet. This is the magnetic material, correct, which will be pulled up. Will be pulled up because the coil magnetizes, this pulls up. You can see there is a spring here in the injector, correct? This injector, what is job of injector? When signal is now, voltage is not given, correct? When coil is not given 0 volt, this is the time axis, correct? So the spring will press this plunger down so that this nozzle is closed by this valve, correct? This is it is a needle valve, correct, like a wedge, right? So this is the injector opening nozzle. This is nozzle, correct? So this needle, this is needle valve, which is connected to plunger, which in turn will be pulled by the coil. You have the coil, so the coil will pull it up. So there's a spring, correct? Spring is holding the needle valve down, so the nozzle is completely closed during this time, correct? When 12 volt is applied, the coil becomes electromagnet. The plunger is pulled up against the force of the this spring, and the injector opens. So there's a gap, correct? So if we say that this is a wedge shape, correct? So this is the needle valve, correct? So this is pulled up. When you pulled up, there's a gap. Basically, you will see that there's a gap is happening, correct? So what will happen? This needle valve will goes up because of electromagnetism. So it may become like this, correct? You can see that there's a gap. So here you have the high pressure fuel, correct? High pressure fuel. What is fuel pressure? I told you, maybe 5 bar, 6 bar, 4 bar, something, correct? So this is the injector, correct? So this is the injector. So this is the hole, nozzle, correct? I told you this may be 50 to 100 micrometer dia, correct? So the fuel is, the high pressure fuel comes out because here the pressure is, correct, less. So this 1 bar, correct? It is 1 bar atmospheric pressure. So here it is 5 bar. So the spray. But what will happen? The liquid will become droplets. The liquid will break into small droplets. The droplet size may be in 100 micron, 50 micron, something, correct? Diameter, droplet, this is a solid liquid fuel, petrol fuel, correct? The liquid fuel which is coming out because high pressure, when it comes out to low pressure, you know that automatically breaks into droplets, correct? Now, this here you have your manifold. The air is going into cylinder because cylinder is this side, correct? It sucks. So what will happen? This fuel droplets will be carried inside the cylinder. As it is carried inside cylinder, because air temperature, room temperature, it will evaporate. So this all the droplets by the time enters into cylinder will evaporate. It will become a petrol vapor, correct? So when petrol vapor, then it mixes with gas. This has O2, correct? Of course, air has nitrogen and O2, this is a predominant. Other gases are very less than 2%. So it mixes with this air molecules, which has nitrogen, oxygen, and goes inside the combustion chamber. There, if you give a spark, then the air fuel mixture vapor, correct? Start combustion, correct? Then it start burning. Then it produces force, downward force pushing the piston out. We know. What is the advantage? Since in the injector, fuel is pressurized by this fuel pump, and injected at high pressure, 5 to 6 bar. The droplets created will be in the maybe less than 50 micron, 100 micron, 20 micron, like that, correct? Depending upon pressure. So smaller the droplet size, and even when the temperatures of the air entering in cold condition, winter also, the temperature lowers, easily they can evaporate. So it will create homogeneous mixture, correct? Once a homogeneous mixture is created, you get lot of benefits, correct? Homogeneous mixture, that means all the fuel is, most of the fuel, correct? Not all, most of the fuel is, even in the fuel injection, in port fuel, PFI, correct? Next slide I'm going to show. Some amount of fuel will be sticking inside manifold, correct? Wall wetting phenomena happens, but compared to this one, carburetor, correct? In fuel injection, port fuel injection, PFI engine, we are injecting fuel not inside the combustion chamber, outside the combustion chamber, correct? And the inlet port. So the 90 or 95% of fuel will be evaporated because the droplets are smaller because high pressure injection. So most of fuel will be this one. So since fuel is injected, this one, better fuel evaporation happens. Why? The finer fuel droplets due to inject a high pressure, 4 to 6 bar, I told you. It can be a little more or high, correct? Don't worry. Because as to compare to GDA, it is much less. Compared to CRDA, it is 100 or 200 times less, correct? So then the homogeneous mixture formation happens because all the fuel is evaporated, it mixes with the air, and the fuel molecules be closer to oxygen molecule, evenly distributed inside the combustion chamber. So when the spark is given, better combustion happens, more torque is generated, correct? So fuel evaporation, this is advantage of fuel injection system, no doubt, correct? Compared to the carburetor. So better fuel evaporation, because fuel is in the higher pressure, so finer droplets, they all evaporate, okay? Then because of fuel is completely evaporated, homogeneous mixture happens inside the combustion chamber. So better combustion happens when spark is given. So when better combustion happens, high temperature is created, so more torque is, correct? The force applied on the piston will be higher, so more torque is created as well by the crank mechanism. Second advantage. So since all the fuel is evaporated, all the fuel is combusted properly because homogeneous mixture. Third advantage, improvement in fuel. No fuel is wasted, correct? So that means fuel economy. You are going to burn all the fuel, so that means you inject less, right quantity of fuel, so you will get whatever torque you want. So you better fuel economy, no fuel is wasted, correct? Better drivability. Drivability means if you want to accelerate, if you press the accelerator pedal, more fuel is injected by the injector, depending based on the command coming with ECU, all the fuel will even more fuel injected because final droplets, all the fuel is better acceleration, correct? Better deceleration, correct? Drivability means when you want to accelerate, you should accelerate. When you want to reduce decelerate, immediately fuel quantity cut off by the injector using ECU, and so engine speed reduces. That's what we call drivability, correct? So if, then third is, if all the fuel is burned properly, proper homogeneous mixture is created. Main thing is this is very important point, correct? If homogeneous mixture is created with right quantity of air fuel ratio, correct? AFR, that you have to decide by the while making what you call a fuel maps, correct? We will see it today itself. Next slide, correct? So AFR is created. That means all the fuel is evaporated, it mixes itself, all the fuel is burned properly because the fuel quantity injected was right enough to mix with air. That means available oxygen molecule sufficient to form H2O plus CO2, correct? No CO or HC unburned, this one, or NOx is created, correct? When homogeneous mixture happened with right quantity, that also in stoichiometric air fuel ratio with catalytic converter, correct? There are two key points with homogeneous transfer, this one mixture at stoichiometric air fuel ratio with catalytic converter at your tailpipe. In that case, you will not get these things. These things will be almost eliminated. You will get H2O and CO2 only. Clean exhaust, correct? Inert gas CO2 plus water vapor, supposed to get, correct? So then that means automatically you are reducing emissions, correct? Better homogeneous fuel mixture happens because of the injector, and better combustion, all the fuel is burned, better drivability, fuel economy, and reduce emission. HC and NOx emission reduces. This is advantage. These are 5 important points. 5 important, but other benefits also we will see as we discuss. Right? So this is advantage of fuel injection compared to carburetor. So now we know that engine needs to be electronically controlled. In the carburetor, all are mechanical. Butterfly roller, throttle cable, all this thing is needed. Here, the fuel quantity is controlled by giving electric pulse. Who is giving? ECU is giving. Correct? Electronic control unit is ECU is giving the pulse. Correct? To injector. 12-volt pulse to open and close the injector. When injector is supplied with pulse, injector magnetizes, correct? The coil magnetizes, the plunger is pulled up, the nozzle, the needle valve opens, through nozzle, fuel is coming. So you open injector for some duration, correct? Generally in the millisecond duration, correct? Injector will be open, the duration of the pulse will be in the order of milliseconds, correct? So if you open injector, and depending upon the pressure of the fuel, correct, whether 5 bar, 6 bar, 7 bar, and depending on size of the nozzle diameter, I told you 50 micrometer or 100 micrometer, whatever the size, then how long the injector opens, correct? Injection duration, correct? Injection duration, that is nothing but injection pulse width. We call it an injection pulse width. Correct? The one next to one is the nozzle size. Nozzle size of injector. I am talking single nozzle, single hole of injector. Correct? Nozzle size diameter. Then before that, another important is a fuel pressure. Correct? Fuel pressure. What is the pressure? How much the fuel is pressurized by the fuel pump. Correct? These two parameters decides how much fuel quantity injected inside the engine during the suction stroke. Okay, here the fuel pressure is already fixed by the fuel pump. If you buy a fuel pump 5 bar, already know. And if you buy an injector whose nozzle size or hole size is say 100 micrometer, correct? That also fixed. These two are already fixed. Only quantity which is variable is injection duration, this pulse duration, correct? This pulse duration is going to vary. Okay, I will remove this, then I will show. So now if I want to inject more fuel, what I have to do? I have to open the injector for longer time. Correct? I will open the injector for longer time. Right? So injector opens here because initially 0 volts at time t. This is time. This is time. Correct? X-axis, Y-axis nothing but injector voltage. Correct? Injector voltage. Generally, injector will be an on-off signal. So ECU develop the on-off signal which is given to injection. Whenever ECU want to inject fuel, when it is going to inject, when inlet valve opens. Correct? So that time this fuel injector will be given 12 volt by this one. A 12 volt pulse is given. So for example, you are giving 2 milliseconds. Correct? Injector is open for this duration is 2 milliseconds. After that, it becomes 0 volts. This is 12 volts. Correct? When the 12 volts are given for 2 millisecond duration. So during the time, the plunger will go up because of electromagnetic action by the coil, the current is flowing. So the fuel, high pressure fuel is coming out. You can see here, this is coming out. So now for 2 millisecond duration, fuel was coming. through a 100 micrometer dia nozzle at 5 bar pressure. There's a formula you can calculate how much fuel injected, how many milligrams of fuel is injected, or grams of fuel is injected. Correct? I say that 10 milligram fuel is injected. Correct? So for that, engine develops for 10 Newton meter torque. Suppose I want to double the torque developed by engine. Correct? 20 Newton. What I will do, I have to open inject for double the time. Correct? I open for 4 milliseconds. Correct? So I will open it for 4 instead of 2 milliseconds. I open injector for 4 milliseconds. Correct? Here it is 10 grams. Correct? For open 2 milliseconds. If I open double, they are proportional. Correct? Automatically 20 grams of fuel will be injected. I'm saying this too much. Correct? And for example, I'm saying, right? Generally inject in milligrams. Correct? Per stroke, per each stroke. Yes, I'm talking single small engine. Correct? So we say the milligrams. Correct? So by controlling the width, if I want less fuel, I open for 1 millisecond. So 5 milligram fuel will go. 5 milligram fuel will go. If I open injector for 3 milliseconds, 15 milligrams. So depending upon how much torque needed, how it is easy, who decides this pulse width, who is controlling on this on-off pulse? ECU. How ECU knows that it has to open whether 1 millisecond, 2 millisecond, 3 millisecond, 4 millisecond, depending upon throttle pedal, how much the driver is pressing the throttle pedal. Correct? When the driver is pressing a throttle pedal, there's a sensor called TPS, throttle position sensor. It is called as throttle position sensor. They call short form is TCS. That sensor, this figure shows that the throttle position sensor gives how much the throttle is open. Then that based on information inside your ECU, there's a map, what we call a fuel map. In your terminology, it is called a fuel map. Correct? It is a 2-dimensional map, which is y-axis, for example, throttle position. Correct? How many degrees it is open. Correct? So based on that, how much air went in, you can already calculate it with the throttle equation. So you conduct experiment and put a table, 2-dimensional table. I will show you. Okay. Now, based on that, the injector will be open, whether 1 millisecond, 2 millisecond, 4 millisecond, depending on throttle position. Correct? So, for example, my PhD work for development of ECU for single cylinder scooter engine. Correct? So, maximum pulse width was 4.5 millisecond, 4 millisecond, 4.5 milliseconds in full throttle condition. Correct? Generally, the ideal condition it was 1.2 millisecond. So, the injector, the pulse duration. Correct? This pulse duration for my single cylinder research by PhD, which I did in 2003 to correct and 5 around that time. So the few injector was opened for by ECU. ECU was programmed such that ideal condition it will open injector for 1.2 millisecond. As you press the increase the throttle, correct cable, the throttle valve opens. That how much opening, there's a 3PS sensor, throttle position sensor, which are attached to the throttle valve. That was giving electrical voltage. It will give 0 to 5 volts. Correct? It will give 0 to 5 volts when throttle is opened by 0 to 100%. That is nothing ideal. Correct? So this voltage was measured by the ECU. Based on that, it will open the injector. That's already the program, what we call a map. So it will open. The maximum was, I think, 4.2 milliseconds. I will show in somewhere. I have a table. Correct? I will show you. So that's how the fuel injection system works. Now you can note down what are the key points of fuel injection system. Correct? Why injection is better than carburation. Correct? Fuel metering with injector, electronic fuel metering with injector, electronic injector. The injector is electronically controlled because it receives electrical from ECU by a pulse width. Correct? Right? Since the width of the pulse is varied depending on fuel quantity, it is called as pulse width modulation technique. It is called as pulse width modulation. Note down these are keywords. Correct? Short form is PWM. Injector pulse is called as pulse width modulated. What happens if you see the pulses in your oscilloscope? Each time during a suction stroke, because engine is go on running, correct? So every, correct, this is first cycle, this is second cycle. During suction, correct? During this, so there are, it can be divided into 4 parts. This time is this duration, this is time axis, correct? This is one cycle time. What is cycle time? I think 4-stroke engine, suction, compression, power and exhaust strokes. It happens 720 degrees, correct? Which is nothing but two crankshaft, yes, two crankshaft rotations, correct? When the piston goes up and down, one time up, one time down, 360 degree. That means crankshaft rotated one rotation. Then come power stroke down, again exhaust stroke up. So there are totally 4 strokes in 4-stroke engine. 4-stroke petrol engine I'm talking, correct? Totally 720 degree. For that, 4 strokes happen. Within that, crank shaft rotates 2 rotations. Okay. Now, so that means the total cycle time is 720 degree. Correct. This can be divided into 4 equal parts. Correct. In the 4-stroke petrol engine, it is divided into 4 equal parts. Correct. So this is the suction stroke. Correct. 180 degree. Correct. So then this is the compression stroke. Compression stroke again 180 degree. Correct. The okay. I think 1, 2, 3 only is there. I have to change a little bit. One. Okay. Correct. From here to here is one cycle. It is divided into 4 equal parts. Suction stroke, compression stroke, then power stroke. This is your power stroke. Then finally exhaust stroke. Right. So during the compression stroke, air is sucked inside the engine. You know that during suction stroke, the injector will be opened. Correct. This is injector opening. 12-volt pulse is given. So injector opens. Correct. So then, but the injector should close before the end of this is deadline. Please see the marking. Correct. Before the inlet valve closes. Correct. After inlet valve, air will not go inside. That means you can inject fuel during the suction stroke, which is 180 degree. Correct. Generally, when you fuel injection for this pulse duration, when we talk about pulse duration, we always talk in terms of time. Correct. I told you in the milliseconds. Correct. How do we calculate? We know that if engine is running at 3000 RPM, correct? Engine is running at 3000 RPM. What is RPS? Divided by 60. So it is going to be 50 RPS. Correct? Revolution per second. So what is the time taken for 7 to this one? You have to divide by 1 divided by RPS equal to time, cycle time. Correct? This is called cycle time. Cycle time T is nothing but 1 divided by RPS. Correct? So if you follow that, so my cycle time T equal to 1 divided by 50 seconds. Correct? Is nothing but 20 milliseconds. Correct? If it is 20 millisecond, it has 4 strokes. So this 20 should be divided by 4. Correct? So that means each stroke has 5 milliseconds. Correct? The duration of each stroke is this duration, which covers 180 degree in crank angle, which is nothing but 5 milliseconds if engine is running at 3000 RPM. A 4-stroke engine. Correct? So next to this is 5 milliseconds, which is nothing but compression. Correct? Power stroke also 5 milliseconds. Exhaust stroke also 5 milliseconds. So this cycle repeats. When injection should be opened? During suction stroke. Correct? What is the maximum duration? If engine is running 3000 RPM, correct? What is the maximum the pulse width or the fuel injection pulse width can be 5 milliseconds. Because if you open injector beyond that time, correct? The inlet valve already closed. After 5 milliseconds, inlet valve is closed. Air will not enter. So whatever you fuel injecting will not go into the particular cycle. The fuel will be outside the combustion chamber. So it is no use. So that means your fuel, if you want to inject fuel, the maximum injection duration will be only 5 milliseconds. Correct? When engine is running 3000 RPM. That's how it works. Okay. Note on the key points. So if you want to inject more fuel, what you have to say? You have to take a bigger injector. Correct? Bigger injector means the hole size is bigger. It's 100 micrometer. I told you, you have 200 micrometer, bigger hole, single. Or take an injector which has 2 or 3 holes. Correct? So each hole is 100 micrometer. There are 3 holes. Correct? If it open, more fuel will be injected within short duration. So you have to calibrate. That is called mapping or calibration. And this one you have to do. Correct? So this is the fuel injection. So next slide shows What is 4 fuel injection? Whatever discussed is shown as a single figure. Correct? You can see that this figure is very important to understand the PFI engine, port fuel injection system. The very good picture because I took it from this website, WThinking, this one. So you can see it. So you have the fuel tank. It is filled with fuel because it is shown in yellow color, light yellow color. Correct? From the fuel tank, you can see that one pipe is coming, which is coming to fuel filter. Correct? Because fuel can have dust particles, something else. Correct? When you get a fuel pump in your fuel station. Correct? There are chances. Generally, it is refined and coming out. There are chances. Now you know that your injector hole size is in micrometer. 50 micrometer, 100 micrometer, very small. If dust particle that, it will go and block the nozzle. Then fuel cannot be injected. That's why the first from fuel tank, the fuel comes to fuel filter. Correct? Then one thing is missing here. I think this drawing is not correct. You have to put fuel pump. Correct? From the after the filter, there's a fuel pump. This is missing in this drawing. No doubt. Fuel pump is there. Correct? Generally, fuel pump is a suck the fuel from the filter. Actually, fuel pump is sucking fuel from the fuel tank. When it comes, automatically because of pressure, sucking pressure, the fuel will go through the filter and the dust part will be removed. Correct? Then pure petrol will come to the pump. This is pump entrance. So here it is body fuel pressure. It is 1 bar. Because fuel tank, it is atmospheric pressure is 1 bar. Correct? So after the pump, this is my fuel pump. Here, the fuel pressure becomes 5 to 6 bar, depending upon. It can be 3 bar, 4 bar is the pressure. So the high pressure. Now, the high pressure fuel is going and entering into the injector. Correct? It goes to injector. Correct? It goes to injector. Okay. So, and injector is closed. Normally, there's a spring loaded injector is closed. Okay. During the suction stroke, I told you, ECU knows that which is suction stroke using a TPS sensor and cam position sensor. Cam position sensor. It can use any of those things. Correct? Or crank angle sensor. Anything can be there. There are many sensors can be used to find whether engine is a compression stroke, suction stroke, compression, or power, or exhaust. It can find out. So when EC knows that based on signal coming in cam position sensor or crank angle sensor, correct? So it knows that is suction. What it will do, it will find out what is engine RPM. Correct? How it finds the engine RPM? There is a engine speed sensor. Correct? So you can see the crankshaft sensor. Correct? Crank is rotating. Crank is rotated. This is called, from this you can find out engine RPM also. Correct? Number of rotation crank happened, nothing but engine RPM. Correct? So that is what connected to flywheel. From that, it is coming out of the engine, connected to gearbox, goes to wheel. So from camshaft position, you can know the engine RPM. This input goes to ECU. You can see the cam position sensor also goes here to ECU. Correct? You can see that there are many sensors in this. Correct? So first we will see what are sensor, then we will understand how it works. So you have cam position sensor. Correct? From this, you can solve. It is also called engine RPM sensor. Engine RPM sensor. Correct? So from this, it gives generally square pulses. Each time when crankshaft rotates 1 revolution, it gives 1 pulse. Correct? So if the engine is running at 5,000 RPM, 3,000 RPM, correct? Running, how many pulses per second? Within 1 second, correct? Within 1 second, you will get 50 pulses. Correct? So these pulses, correct? These pulses are going. These pulses are going to ECU. ECU counts this number of pulses. Inside ECU microprocessor, there's a counter, electronic counter. It counts number of pulses coming within 1 second. From that, it always knows what is engine RPM. Correct? This is called crank position sensor and also called as engine RPM sensor. Okay, it has a 2 position. Then you have what you call a engine temperature sensor. Correct? So engine cool. So sometimes you know that this is a cooling system. Correct? It put on the cooling system that engine coolant is flowing. Inside that, it will be sensor is projected so that the engine temperature can be known. We will see what for it is. Then you have another sensor which is called TPS. Correct? So this is called throttle body and throttle valve. Correct? This is circular is throttle valve which control the air going inside the engine. When driver presses the throttle pedal, correct? When driver pedal sits and presses the throttle pedal, holding the steering wheel, correct, and sits on this one, correct. When he presses this, so what will happen? The throttle valve opens or closes, correct. Ideal condition, throttle will be closed. This is a throttle valve, which is also called butterfly valve sometimes, will be completely closed. This is a cross section, this is a pipe. This is called manifold, correct. The whole pipe is called as manifold, correct. The manifold is connected to what? This is the inlet port. This is engine inlet port, correct. So this is called as exhaust port, correct. So this is inlet valve, inlet port, and this one is called inlet valve, correct. Similarly, this is exhaust valve, correct. So then you have your piston. This is the engine cylinder. We know that, correct? Engine cylinder, right? Then you have one more sensor. You can see here. I'm circling, correct? So this is nothing but oxygen sensor, which is also called EGO. What is that? Exhaust gas oxygen sensor, correct? It measures amount of the oxygen coming in the exhaust. Using this sensor, you can find out what is the air-fuel ratio. Air-fuel ratio of can be measured using EGO sensor. Actually, it is not measuring air-fuel ratio. It is measuring amount of the oxygen coming out of the exhaust, correct? But we know that how much oxygen entering here. What is that? What is the atmosphere is air volume, correct? If you take 1 liter of air, correct? What is the percentage of volume wise? What is the percentage of oxygen? What is the percentage of nitrogen? Any idea? Hello?
Nitrogen is 78%.
Pardon?
Nitrogen is 78%.
Okay.
Oxygen is 21%. 21%.
Okay. So 99% is gone, correct? So
Yes.
the remaining 1% only carbon dioxide, all other gases. Okay. So we know as a volume is 21% is O2, correct? So when inside combustion, what happens? The H and C, correct? Hydrogen molecules will join with O2 in the air, this O2, and forms H2O, correct? Similarly, this will combine with O2, correct? Combine with O2 produces CO2, supposed to this one, correct? But it doesn't happen. Completely all the oxygen molecule will not combine with C and H, correct? That's not the problem. Because of that, you are getting HC, CO and NOx plus H2O and CO2. All these things are created, correct? So that's what is coming out of your exhaust, correct? So that means some amount of oxygen will be still coming. O2 also will be coming. And of course, N2 also is, nitrogen is there, correct? All the nitrogen is not converted to NOx. All the oxygen is not converted to CO2 or CO or H2O. Some amount of oxygen is still coming out because of imperfect combustion, correct? That oxygen level is sensed by the oxygen sensor, correct? Now it generates electrical signal. EGO sensor produces electrical signal. Based on that, you can find out whether it is what is the air-fuel ratio, correct? So AFR can be calculated. Now I will remove all these things. You can still see clearly. So you have 5 sensors. Most widely used 5 sensors is EGO sensor, also called oxygen sensor. Cam position sensor is needed. We calculate engine speed. Then you need a sensor which is called a TPS sensor. This is called TPS sensor. Here it is shown here, correct? This assembly is complete, correct? So this is nothing but the 3 sensors: intake air pressure, intake air temperature, then throttle. This valve, how many degrees open, correct? Normally it will be completely closed, no air can go in except small bleeding, correct? This is called bypass, correct? The throttle button is a bypass. This is called an idle air valve, idle air valve or passage, correct? Bypass control, idle air valve. Normally throttle will complete when you are not pressing throttle pedal by the driver. You start the engine, which is called as idle condition. In idle condition, this throttle valve or butterfly valve will completely close so that no air can go like this. But there's a small bypass. You can see a small pipe through which the air will go through this, bypassing the throttle valve. Correct? That's why it's called bypass valve, idle valve. So it is the quantity of air will be very, very less. 5% maximum or 2% or maximum air going when throttle is fully open, 10% throttle. 10% throttle means the valve will completely open. This is just free flow. Air will go full. But how much air going depends upon the diameter, correct? This diameter of the manifold. Correct? It is a pipe, correct? It is a pipe, cylindrical pipe, correct? So the pipe diameter, inner diameter, and that means cross-sectional area, correct? Cross-sectional area of the manifold decides what is the maximum air can go when throttle is 10% open. That means throttle valve is fully open. That time the bypass valve may be closed. May be closed, correct? It can be open, this other, but generally, but when idle condition, this throttle completely closes only through the bypass pipe. By control opening the valve, the air will go in idle condition, correct? Idle air control. Okay, so you have a TPS sensor, throttle position sensor. It is called TPS sensor. Inlet air temperature sensor. It is called IAT. Short form is called inlet or intake air temperature sensor. Throttle position TPS and inlet air pressure sensor. Correct. These sensors are attached in the manifold. Okay, so 1, 2, 3, totally 3, correct? Then these are the 5 sensors, most widely used 5 sensors for fuel injection, for fuel injection system, correct? So we need engine speed, correct? Engine speed from crank position sensor. EGO sensor gives the actual air fuel ratio of the engine, correct? TPS sensor provides how much throttle is open, correct? There's a throttle body equation, correct? Throttle body equation, correct? And by you know that how many degrees the throttle valve open, is the butterfly valve open. Based on that, you can find out what is the amount of air flow in volume, correct? So there's equation, there's a throttle body equation, where you have to fit the how many degrees throttle open, what is the size of the throttle body, this size diameter, all those things you fit, then you know that how much air is going for given. So the throttle is opening from 0 degree to 90 degree, correct? 90 degree open, that means for 10% open. Throttle is 10% open, there is no restriction, all air can go in. Of course, there is a small restriction because throttle is made of even the thin plate, the cross section of thin plate will reduce. This spindle wheel is there, correct? Support spindle, all those things. They restrict amount of air. You have to calculate all those things. Based on that, you go. When when idle condition, throttle is fully closed. There is 0 degree, no opening. So throttle will open from 0 to 90 degree, fully closed, fully open. Okay. So that is sensed by TPS sensor. Using throttle body equation, correct? Throttle equation, what it needs, it wants this theta, correct? The theta varies from 0 to 90 degrees, correct? That if you give it a throttle body equation, and if you know the size of the this manifold, the tube size, then you can find out volume of the air entered inside this cylinder during the suction stroke. So these sensors are used, this is how it works. So what happens when driver presses the throttle or start the engine, correct? Air is going in idle condition also like this. Correct. So now we know how much air is idle condition. You know these all value of the air going. Correct. So you can program the ECU such that it injects right quantity of fuel, so the engine will running at idle speed. When you press the throttle, correct, this bypass valve may close and all air will go. So the throttle opens depending upon position. If you press full throttle, the air will go. So that information, all the sensor information goes to ECU. ECU will generate what it generates. So in petrol engine, there are 2 control parameters. One is injector control. signal you have to generate. ECU should generate inter-control signal. Then next one is spark signal, spark control signal, spark plug control. Correct. So we know that who is generating signal? The ECU. Correct. And how it generates based on the program or code which contains maps. Right. Air fuel map as well as the spark timing map. I will show that how you can do that. Correct. So based on that, the controller gives control signal. It opens injector. Here only the PWM signal comes. Correct. This is one cycle. This is the first cycle. This is the second cycle. Correct. So it repeats as the engine is going, third cycle like that. Every time during the suction stroke, the injector will be opened. ECU will generate this pulse, give it to injector, the fuel will be injected. Now you can see that where is the injector is placed. The injector is placed such that the fuel coming from the injector nozzle will hit the inlet port. This is nothing but inlet port. Inlet port of the engine, right? Or intake port. Some you call intake port or inlet port. Where is it injecting? It is injecting outside the. This is outside surface, correct? So this is the this is nothing but your valve, inlet valve, correct? So this is outside. The fuel will come and fall and hit on the outside surface of the inlet valve. Because that is very important. That is called locating the injector, correct? The injector should be located in particular angle in the near the inlet port, such that fuel coming from the nozzle, majority, at least 80 to 90% of the fuel. I said you have to design such angle. You fix the injector such angle so that fuel coming where they should go and hit the outer side of the inlet valve, not on the sides of the, correct? So this is the outer valve, correct? Outer surface. Correct. So it should come and hit here, majority. But this is called manifold, correct? I already told you inlet manifold, correct? So some fuel will be still touching on the inlet manifold, correct? So that means again the valve wetting phenomenon will happen. Valve wetting phenomena, right? It happens. Why? You supposed to go inside. If it hits the inlet valve, correct? What will happen? Inlet valve is exposed to internal, this is a combustion chamber, flame, correct? So as the engine start coming, internal temperature of the combustion chamber can go up to 800 degrees during the, when the fuel is burning, air fuel ratio is mixture. So the valve get heated up. So the outer surface temperature will be around 200 degrees, correct? Approximately, I'm saying 200 degrees centigrade, correct? So when the fuel goes and hits on the valve, because what is air temperature? I told you it can come from minus 40 degree to maybe plus 50 degree in summer in desert condition, correct? So the air temperature will be around that only. That fuel, now if the fuel is injected, correct, air is entering. So because high temperature in summer, all the fuel will be evaporated. Already because high pressure, correct, fuel is a high pressure. What will happen? The fuel droplet will be micrometer size. So all the fuel will easily evaporate in summer. Even around 30 degree in Chennai also, most of the fuel will be evaporated because the fuel is the injector high pressure 5 to 6 bar. So the fuel droplets might easily evaporate. Even in winter side, correct, 5 degrees something, at least 50% of fuel will be, or 20% will be injected during the starting condition, correct? Cold start, we call it as a cold start, correct? Cold start condition. Correct. So when first time when the injector opens, the fuel goes and hits on the outer surface of the inlet valve. What is temperature inlet valve? I told you it is cold condition. It can be minus also. Correct. So that time also definitely fuel. And first time when fuel is injected, when you start your engine, correct? Fuel injected first cycle, correct? In the first cycle during suction stroke, correct? Fuel is injected. This is my first cycle. Correct. So this is my suction stroke. This is the compression. Correct. This is my suction. This is compression. This is power. This is exhaust. One cycle. Correct. First cycle, when you crank the engine, correct, The piston goes down, vacuum is created, inlet valve opens, and is ECU gives a pulse, say open for 4 millisecond or 2 millisecond, whatever, fuel is injected. Correct? Where is injected? Fuel is injected on the outer surface of the inlet valve. Correct? But some fuel is hitting on the manifold outer valve also. This fuel will be sticking, valve wetting, and this is a problem. Correct? Just like carburetor. Carburetor, more valve wetting will be there because the carburetor is here. The air with petrol, these droplets are traveling. Correct? Instead of injector, it goes. So more fuel will be sticking to the valve. Correct? Valve wetting. That is predominant in the carburetor. I told you. In case of port fuel injection, we are not mixing fuel here. Correct? Air. The throttle valve control only air. See, the throttle valve is inside your carburetor. And also you have jet, correct? In the engine, correct? You can see that there's a throttle, correct? So this is your throttle, very close to this one, carburetor, and this is jet. They are very close. So from here, liquid fuel is going, bigger droplets and fuel, the air fuel mixture with water, the petrol droplets are moving. So more fuel can be sticking to the valves. So more valve wetting problem. Correct? Valve wetting happens. More fuel may be sticking here instead of entering into combustion chamber. Correct? Maybe 20% fuel, 10% fuel be sticking to the manifold valve itself in carburetor. But in case of fuel injection, where we are injecting, we are locating the injector such that fuel is injected directly under the inlet port outside valve. Correct? But when you're doing first stroke, some fuel will be sticking. They won't evaporate. Some fuel will be sticking on the manifold also near the inlet port. That also won't evaporate. But once engine combustion starts, what will happen? The valve get heated, inlet valve get heated up. Correct? Each time when combustion happens, what will happen? This valve will get hotter and hotter, this surface. Correct? From room temperature become this one, it can reach up to 200 degrees centigrade. Correct? Within 30 seconds, 40 seconds, by the engine is running. Correct? So 50 times this one, combustion happens every time during the power stroke. Correct? And the entire surface, all this area will be get heated up. Correct? Including this valves, all this thing will get heated up. Now, once the engine get heated up, if fuel is injected on the valve, it is around 200 degree, all fuel will be automatically evaporate and become fuel vapor. Correct? It will become fuel vapor. So very, very important is designing the injector location. Correct? Which is called as locating the injector. Correct? At what angle it should, the spray from the injector should such that it goes and hits if you are trying to design a new engine, fuel injection system. Correct? Locating injector, what angle, all these things with respect to this. See that you have to do a lot of it. I did it. That's why I'm able to talk all these things. In year 2003, I was doing all these things. I told you that my PhD itself, developing the ECU for indigenous ECU for single cylinder engine for a petrol, this one, scooter engine, 125. I took the engine, I removed the carburetor, I made this manifold, throttle body, correct, and bought the injector and made a throttle body such that did a lot of physically. You have to see the manifold here looks like this one simple, correct, straight pipe. Actual manifold not straight. It will be like to twisted all those things. So the air going inside should go and swirl inside the engine. Correct? You have to make swirling. Air should swirl. Correct? Why? If it swirls like a tornado, you know the petrol droplets which is not evaporated will be easily evaporated and will mix. See, petrol will evaporate, but it should not concentrate in one location. It should be easily distributed to make a homogeneous mixture. So the manifold is designed such that it creates a swirling action. The air entering the cylinder will not just go inside. It should go and swirl. Correct? So there is a combustion chamber design and manifold design. These are very important engine design. If you are working, you will know. Right? So that means manifold is not straight. So you have to did lot of experiment, took the engine cylinder, open the cylinder head, correct, and try to make the manifold, because I fabricated all these things in the workshop. Nothing was readily available. I'm talking around 15-20 years, 15-17 years before. No fuel injection system available for two-wheelers, correct? Only four-wheelers have, correct? I have this one. Even Maruti 800 that time, where they're selling Maruti 800, it has only carburetor. Even the car had only carburetor, only, no fuel injection. Correct. So the whole my research was developing ECU for single cylinder engine. This was a research project. So I manufactured each and every component of fuel injection system, manifold, injector I bought it. All other things I have designed. Correct. Such as that. So locating injector, correct. We have to do. So this is the cross section view of the. Okay, I think time is up. 7 o'clock. Hello. Hello. Yeah. So
It is 7:10.
yeah, sorry. No, one more thing. I'm telling you, please remind me around 6:50 because while teaching, I may not looking to watch all these things. You can please interrupt and say that what is the time? Around 6:50, you can tell. I can stop the lecture. We can take next because we may have somebody you may have to catch bus, maybe inside company. Correct? Already evening 7 o'clock. You remind. Okay. Thank you. We will next class. We'll meet on Monday. Okay. 6 o'clock.
Okay, Professor.
Thank you. Sorry for the late.
Thank you.
Okay. Please remind me. If somebody can remind. There's nothing wrong in it. Correct? Kind of you. Bye.